Alright, a slightly harder navigation problem, and a type that you'll find quite frequently. It's not, in this case, a trip with navigation, it's more like a surveying problem. We've got a triangular paddock with two fences that have been completed from a particular location. We've been given their bearings and how long they are. Remember that bearings aren't angles, they're the direction we travelled, but we can use them to find important angles. So we read the question carefully. From location D, one fence line is on a bearing of north 23 degrees west for 400 meters. The other fence line is south 55 degrees west for 700 meters. Find the length of fencing needed to complete the paddock. We always start with the compass rose, and our compass rose, in this case we assume we start at location D because we always start where the bearings are from. Often that's where we start our trip, but since no one's travelling in this case, they've given us a bearing from location D. So we put our compass rose on location D, and we draw in our fences. North 23 degrees west. Try to be reasonably, it doesn't have to be accurate, but you just have to get approximately the right sort of direction. And I've got a distance there of 400 meters. So that's my first fence line. My second fence line is south 55 degrees west. So go south, then 55 degrees towards west, and for 700 meters. Now you'll see why, if you just sort of randomly draw in lines and don't pay much attention to the length, it can be very misleading, especially, they haven't asked me for this here, but when I put that third fence line in, if I had the situation where I needed to get the bearing of that line, say I had to go from, I'll call it point B, and get up to the top of the fence line, and I needed the bearing, if I'd drawn that really carelessly, it would be very difficult to understand what the bearing might be. So try to be a little bit accurate. Put our angles in the correct spot, 55 degrees, just in there. Now the length of fencing that they want is side D opposite point D, angle D. We need to find some more information. I've got two sides, but I don't have any angles in the triangle. But you'll have spotted this set of supplementary angles, 23 degrees, 55 degrees, and the angle in between them will add up to 180. So 180 minus 23, take away 55, is 102 degrees. Now I've got two sides and the included angle, and I can find the opposite side, which is the side I want. If you were confused at this point, you felt your diagram wasn't helping you, then draw a new diagram just with the triangle without any compass roses. Label our sides. Let's draw a triangle. So we've got angle D and side D. I named this B, so that's side B. So I guess we've got angle C and side C. Really, you could have labeled them A, B, C. It doesn't matter. Check which rule we can use. We don't have a side and an opposite angle. We do have two sides and the included angle. So that's going to be the cosine rule for finding a side. c squared equals a squared plus b squared minus 2ab times cos c. Now yes, we are finding side D, so just substitute D in when we get to that point. That's acceptable. We need to square our sides. 400 squared plus 700 squared. 2 times 400. You'll notice we've got some very large numbers in this case. Substitute all your values in. And once again, d squared, not d. But of course, really all I want to do is find the square root of that entire big, long, complicated sum. So, d and look, we'll use up a ridiculous amount of time with me typing this in. Feel free to skip through and get the answer. The square root of 400 squared plus 700 squared minus 2 times 400 times 700 times cos 102 degrees. Remember, you don't need to put the degrees sign, and enter, and that fence line is 875 meters long. Now if I was making a fence and I knew it was 875.4 meters long, and I did normal mathematical rounding down, I would be very, very annoyed if I cut 875 meters of wire and, 875 meters of wire, and then discovered that I was 0.4 out. Honestly, if I was giving this answer, I would say that was 876 meters of wire are needed. So, draw your diagram, put your compass rose at the starting point, identify your triangle and find any angles that you can. Look for alternate angles, supplementary angles, sometimes complementary angles. Use the sine or the cosine rule or right-angled trigonometry and find your distance or your angle.